In today's lesson, we'll talk about solving systems of linear equations in two variables. In this particular video, we'll focus on solving by graphing and by substitution. A solution set of a linear system contains all ordered pairs that satisfy all the equations of the system at the same time. So a linear system basically being an equation with two variables. And a solution set would be an x and a y, or coordinate point, that would be a solution for however many equations you have. In this case, it will be two equations. The first method we're going to be talking about is graphing. What will happen is you will be given two equations, and you will have to graph each one individually. Once you graph them, you look to see where they intersect. The intersection will be the solution and satisfy both equations. So the first equation that we see will be fairly easy to graph if I put it into slope-intercept form. Y equals negative 2x minus 5. It's extremely important that you have a straight edge and you are very accurate, because the accuracy will make a difference when you're finding the solutions. The next one, you can either do slope-intercept and get y by itself, or you can find the x and the y intercepts. Let's put it in slope-intercept form. Plot the y-intercept, down 1, right 3, and I'm going to go the other way because I can see you'll see that we want to go to the left side, and I actually started doing the slope incorrectly. Up 1 to the right 3, but now I'm going to go down to the left, because rise over 1 is up and then right. And what you'll see is when we go down and left, as if it was negative 1, negative 3, they will intersect, let's see if I can get that line straight, right here at the point negative 3, positive 1. Now, I can tell that this is a solution for both equations, because if I were to plug it in, 2 times negative 3 plus 1, that would give me negative 5. And if I plug in negative 3 plus 3 times 1 equals 6, that works as well. So negative 3, 1 is our solution. Let's take a look at the next example. Y equals 2x minus 4 and negative 4x plus 2y equals 12. So if I have it's already slope-intercept, so go down negative 4 up 2 over 1, and I can connect my graph. Over here, I'm just going to manipulate it, and again, I'm going to put in slope-intercept. Y equals 2x plus 6. And if I go to graph my intercept at 6, up 2 over 1, up 2 over 1. Now if I go down and left, you'll notice no matter how far I go, the lines will never intersect. And the reason because of this, and you'll remember this from the last chapter, is that my slopes are the same. If my slopes are the same, there will be no solution, which is called inconsistent. Now, let's take a look at number 3. We'll use the same equation, y equals 2x minus 4, but then let's manipulate this equation, very similar to the other one we had up there. If I move it around, I get 2y equals 4x minus 8. Get y by itself, y equals 2x minus 4. And what you'll notice is now this equation is the exact same equation as the other one. So if I were to graph this on the Cartesian plane, you'll notice that the two graphs overlap each other. that would mean that all those solutions of that graph would be correct. So it's called infinitely many solutions because there are infinite many pairs of points on the graph. The next method is substitution. What you want to do with substitution is you want to look at the two equations and basically pick out the variable that would be easiest to get by itself. You'll get it by itself, and then you will plug it into the other equation. And that's the most important thing, to make sure it goes into the other one. Now, if I look at our two equations, the easiest variable to get by itself would be that y. So I'm going to manipulate that equation to get y equals negative 4x plus 5. And then I take whatever that equals, and I'm going to substitute, just like the name says, into the other equation. So we will get 2x minus 3. Notice the coefficient stays there. The variable is the only one getting replaced. Equals 13. And then I'll solve like a normal equation. I'll distribute the 3, combine like terms, and solve for x, which happens to be 2. Once I get that first part of the solution, I can plug it back into any one of the equations. I can even go to the one that was manipulated. So y equals negative 4 times 2 plus 5. That's negative 8 plus 5, which is negative 3. So my solution is 2, negative 3. And again, I can check this by plugging it back into each equation. We're going to do substitution again. You'll notice that in this case, if we look at all 4 variables, there's not really one variable that sticks out to be easy to get by itself. And you'll even notice the second one has fractions. The easiest way to deal with that, I believe, is to multiply by the common denominator to get rid of the fraction. So the common denominator here is 4, and I'll multiply it throughout the equation. 2x plus y equals 2. That way, you'll notice y is easy to get by itself, and I'll manipulate that to get y equals negative 2x plus 2. Now, since y is by itself, I'll take that, substitute it into the other one. Negative 2x plus 5 times the quantity, negative 2x plus 2 equals 22. I'll distribute. Combine like terms. X equals negative 1. I'll take that. I will plug it back in. Y equals negative 2 times negative 1 plus 2. So 2 plus 2, y equals 4. So my solution pair is negative 1, 4 for this problem. We'll take a look at one last one. If I take this one right here, and I manipulate to get the y by itself, because that would be the easiest to do. And then I take that, plug it into the other one, get negative 8x minus 4 times by negative 2x minus 6 equals negative 24. Negative 8x plus 8x plus 24 equals negative 24. And you'll notice that your variables cancel out and you get 24 equals negative 24. Well, this is false. If this happens, where our variables cancel out and it's a false solution, that will make it inconsistent or no solution. Now, on the other hand, let's just say that this would have been positive 24 instead of negative. that would have meant that it is infinitely many, because basically no matter what you plug in, the solution will be true, whereas for the other equation, no matter what you put in, it would not be true. That's it for today's lesson. We will be talking about elimination or linear combinations tomorrow, along with 3 variables.